Good day, students. My name is John Ubodo, so we'll be considering the term coordinate geometry today. And in coordinate geometry, we want to look at how we can locate points in the XY plane and the equation of a line, gradient of a line. And also we look at the midpoint theorem, and we look at intersection of two or more lines and how to get distance between 2 points in an XY plane. Okay, so coordinate geometry is one of the most important and exciting ideas of mathematics. In particular, it is central to the mathematics students which meet at school. It provides a connection between algebra and geometry through graphs of lines and curves, especially when you are representing a point with respect to the XY plane. Okay, so the XY plane that is represented, we have the x-axis and the y-axis. Here we can represent a point P, such as this. We have a point P. Okay, let's look at the point P as x, y. We can represent it as this. So we have this point and this point. Let's say that y-axis and x-axis, and this is a point P. Okay, so this point is x and this point is y. So this is a point x, y. Okay, so we can usually represent a point with respect to this. We can say, okay, if point P is 2, 4, that means that x is equal to 2 and y is equal to 4. So if this is possible, how do we represent it on the xy plane? So when we have the xy plane, we have the x and y axis, the y and the x. We have this point as 0. Let's assume here is 1, here is 2. Okay, and then here we have 2, 4. So since x equal to 2 and y equal to 4, so we can trace the point around this point and trace it here. So we have this point P. And that point P is the point of 2, 4. At that point, x equal to 2, that is between these two, we have x equal to 2, and from here to here, from the origin to this point, y is 4 units. So x is 2 units here and y is 4 units. So this is a simple way of representing a point on the xy plane. So the xy plane here, we are going to look at how we can find the distance between 2 points. How do you find the distance between 2 points? In coordinate geometry, to find the distance between 2 points, we consider the point given, then we consider the Pythagoras theorem. And let's consider the point given in an xy plane. So we have y-axis and x-axis once again, and we have 2 points, P, x1, y1, okay, and the Q as x2, y2. So if those 2 points are given, let's assume that this is point P, and then here is point Q. Okay, so to represent point Q, we have this as x2, and here as x1. So from here to here, we have a straight line. Okay, so we have this forming a triangle here. This is point Q, remember, and here is point P. So this point as well is y1, that is y1, and here is y2. So the distance between this point and here can be given as delta y, and that is y2 minus y1. And the distance here, which is delta x is equal to x2 minus x1. So if we look at the shape there, we have a right angle triangle. So using Pythagoras theorem, theorem, we can say that PQ squared, we consider here to be point M, is equal to PM squared plus QM squared. So if that is possible, so our PM is equal to delta x. So we have delta x all squared, and QM is equal to delta y all squared. So when we substitute the values of delta x and delta y, PQ is equal to square root of x2 minus x1 all squared plus y2 minus y1 all squared. So we have a distance between the 2 points. Distance between points P and Q, given by this formula stated here. So, considering this, we can also look at some examples under this aspect. If you are given point P as 2, 4, and point Q as 1, 0, let's find the distance PQ. Distance PQ. How do you find distance PQ? To find distance PQ, we apply the formula PQ is equal to square root x2 minus x1 all squared, y2 minus y1 all squared. Considering your values, we have x1, y1, and x2, y2. So we substitute into the relation. So we have x2 as 1 minus x1, which is 2, all squared, and y2 as 0 minus y1. y1 is 4, all squared. So we have 1 minus 2 is minus 1 all squared. You have 1 plus 0 minus 4 is minus 4 all squared. You have 16. So we have 1 plus 16 is 17. So you have root 17. Square root of 17 can be obtained by using your calculator, but we can leave it this way. Okay, so that is the distance between 2 points. How do you find the gradient of a line? Gradient of a line. We look at the next one, which has to do with the gradient of a line. To find the gradient of a line, we apply the same xy plane coordinates using this, and we have a line that is moving through point P and point Q, and the same line, we have point represented here as x1 and here as x2. We form a triangle again. Okay, so we have here as delta y and here as delta x. Okay, here is y1 and here as y2. So the slope of this line is given as slope, on the right, slope equal to gradient. Slope is gradient, and gradient is delta y, that is change in y axis, divided by change in x. So you can write change in y axis, or vertical axis, divided by change in x axis. Change in y axis divided by change in x axis. So we have y2 minus y1 divided by x2 minus x1. So that is the slope of the graph, or of the line PQ. Okay, so we can use this to also find the angle of inclination of the line to the horizontal. Remember that this angle here and this angle here are equal, theta and theta. If I call this theta 1, and I call this theta 2, that means theta 1 equal to theta 2. That is the inclination to the horizontal axis. And if we consider that, we can use the SOHCAHTOA, and we say that tan theta is equal to opposite divided by adjacent. Opposite over adjacent. Now the opposite here is delta y, and the adjacent is delta x. So we still have the same thing, y2 minus y1 divided by x2 minus x1. So therefore, we have tan theta equal to y2 minus y1 divided by x2 minus x1. Okay, so this formula we use to find the angle the line makes with the horizontal axis. We can find the angle by saying theta equal to tan inverse function, y2 minus y1 divided by x2 minus x1. So we can look at an example to solve and see how it is applied in solving such problems. So let's see this example. We're given 2 points, point A, 3, 2, and point B as minus 1, 4. We want to find the what we call the distance between point A and B, the gradient, and the angle the line makes with the horizontal axis. So we're looking for three things. One of them is the distance. Distance AB. Distance AB. The second one is the gradient. We talk about the gradient of line AB. And the third one is the angle. The angle the line makes with the positive x-axis. Okay? So how do we do that? So we have this. We're given the points 3, 2, so and minus 1, 4. So we have the distance between the 2 points AB. Distance AB is square root x2 minus x1 all squared, y2 minus y1 all squared. And here we can identify here as x1, y1, and here as x2, y2. So therefore we have this x2, which is equal to minus 1, x1 is 3, so all squared, plus y2 is 4, and y1 is 2. So we put it there and substitute. Minus 1 minus 3 is minus 4 all squared. That is equal to minus 4 squared plus 2 squared. And that is 16 added to 4, which is equal to root 20. So we have square root of 20. So with your calculator, you get the square root of 20. You get the answer to that. Now, we can also find the gradient. What will be the gradient of the line? The gradient of the line that is given. So to find the gradient or the slope, the gradient of the line is delta y over delta x, and that is y2 minus y1 divided by x2 minus x1, and y2 here is 4. Subtract y1, we have 2. x2 is minus 1, and x1 is 3. So we have this. So we have 2 divided by minus 4. 2 divided by minus 4 is equal to minus half. So this is the gradient. Or you can say minus 0.5. Okay? In any way you can represent it that way. So we have the gradient and the distance between the points A and B. We have calculated that. So let's see how we can find the angle the line makes with the x-axis. How do you find the line? If we are given that the gradient which is known is equal to delta y over delta x, and that is minus half, and we are looking for the angle it makes. So what is the angle? So we have tan theta is equal to delta y over delta x, and that is minus half. So therefore, theta is equal to tan inverse minus half. So you can solve this and get the answer using your calculating device. You find the value of the tan inverse of minus half. Okay, so that is for that. We want to look at other aspects. Here we are going to look at what we call the midpoint. The midpoint is more or less known as the center of a line or the center between 2 points in the xy plane. Now when we look at the midpoint, how do we find the midpoint? The midpoint between 2 points. Let's consider 2 points, P, as x1, y1, and Q as x2, y2. How do you find the midpoint? To find the midpoint, we have this graph. We have the y and x axis. Okay, let's say this is a line where we have this point as Q and this point as P. So to find the midpoint between them, we can use also the concept of the slope concept. Here is the center, which is M. So if we consider this to be the center, we draw and complete this to be this, and we have this point as the midpoint. So this point, the coordinates is or are xm, ym. That means at this point here is xm, and this point here is ym. And here is point y2. Okay, this is y2, and this is y1. And here we can get this point as x1, and here as x2. So considering this, we can find this midpoint. How do you find that? So we use the slope, or considering the slope. If the slope is m, okay, if the slope is x, we can say delta y divided by delta x is equal to, we can say from this point to this point. And that will give us y2 minus ym. y2 minus ym divided by x2 minus xm, okay, is equal to, we can say from here to here. That means we have ym minus y1 divided by xm minus x1. So we can equate these two terms. Let's equate the two terms and see what to give us. Okay, so we have the first one, y2 minus ym divided by x2 minus xm is equal to ym minus y1 divided by xm minus x1. So with this we cross multiply and make x and y the square formula, that is xm and y. So by the time we do the simplification, we are going to have xm and ym being equal to y, can say x, okay, say x. Okay, so we can get that, we get the, so that will give us x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So this will give us the midpoint. This will give us the midpoint. So if you are given 2 points, P1 as 0 and 4, and Q as, okay, let me say P2. It's P2. P2 as 2 and 6. We want to find the midpoint between P1 and P2. So to find the midpoint of P1 and P2 will be given as xm, ym coordinates, and that is x1 here will give us this, and this is our y1, and here is x2 and y2. So when we slot in the values, we have 0 plus 2 divided by 2, comma, the second one is 4 plus 6 divided by 2. So finally we have 0 plus 2 divided by 2 is equal to 1. So we have 1. This one add and divide, we have 4 plus 6 is 10. We have the answer as 5. So this is the midpoint between the points P1 and P2, whose coordinates are given at a particular time. So we can use the midpoint theorem to find the center or the midpoint coordinate by using this concept. Okay, the next one we'll be considering here is the equation of a line. Now there are two terms used to find the equation of a line. Whether we consider what we call the intercept form, using y equal to mx plus b, or the slope form, using y minus y1 over x minus x1 equal to y2 minus y1 over x2 minus x1. So let's see how we can apply that and solve. So we're given equation of a line. How do you find the equation of a line? Considering the coordinates. Okay, equation of a line. So we're given a line. Let's say this is a line that is passing through the xy plane. Okay, we have this. That is a line. And how do we find it? Using the slope concept. Let's use the slope concept. We have this point here, P point and Q point. So if we consider P point and Q point, we have this point as x1, and we have this point as x2. We have this point as y1, we have this point as y2. So we want to find the equation of this line. To find the equation of the line using the slope concept, what we do is you find the slope. What will be the slope? Considering a term. Let me say that there is a point here. Okay? Where here is x and here is y. So we can use this and say the slope is equal to m. So m is equal to y minus y1 over x minus x1. And that same m is equal to y2 minus y1 over x2 minus x1. So we can equate these two, and we have our slope concept. Y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1. So if we consider this to be equal to m, we can say y minus y1 over x minus x1 is equal to m. So cross multiply, the answer there will be equal to y minus y1 is equal to m in brackets x minus x1. So we have this as the equation of a line. You can open the brackets, y minus y1 equal to mx. mx minus mx1, y is equal to mx minus mx1 plus y1. So we have this as the generalized form, but we can leave it in this form, or if this is preferable. So we have these two forms of equation of a line. So let's see an example of finding the equation of a line when 2 points are given. You are given 2 points. A, you are given 1, 2, and B, you are given 0, 3. What is the equation of the line joining points A and B? What is the equation? So to find the equation of the line joining point A and B, we have, let's use the slope technique. So we have this as x1, we have this as y1, and here as x2, and here as y2. So we have y minus y1 divided by x minus x1 is equal to m. So m is the slope. So we have the slope. So let's find the slope. M equal to y2 minus y1 over x2 minus x1. y2 is 3. y1 is 2 divided by x2, 0, minus x1, 1. So we have 1 divided by minus 1. That is minus 1. Okay? 1 divided by minus 1 is minus 1. So we have this as the slope. So we can substitute this into this expression, y minus y1. The y1 there is 2. And the x1, x minus x1 is equal to minus 1. So we simplify further. We have y minus 2 is equal to minus 1 in brackets, x minus 1. So we have y minus 2 equal to minus x plus 1. Y plus x equal to 1 plus 2 when you collect like terms. So we have y plus x is equal to 3. So this is the equation of the line joining points A and B. We can also put it in the other form and say y equal to minus x plus 3. We can put it in this form. So if it's in this form, that means we are saying y equal to mx plus c. Y equal to mx plus c, where m is the slope. M is the slope, and the slope here is minus 1. And c is the intercept. C is the intercept. And this intercept here is 3, which is the intercept or the point where the line crosses the y-axis. You can sketch a line of that equation. So we have this. Just sketch, give a sketch. It passes through this point, and this point is 3. Okay, and you can have your point represented different. But the intercept here, c equal to 3. That's the line. Okay, but because it's sloping downward, so we may not have it this way. So we can have it in the other form. Okay, let's have it in the other form, which is using the other format. Since the slope is negative, it will slope down. So we have this sloping down at this point. We have 3, then it slopes down in this form since the slope is negative. So yx, the slope is negative. So since the slope is negative, the graph will slope down the curve. So we have the equation of a line using the slope concept and the intercept concept. Okay, so we are going to look at what we call the, apart from distance between, we're going to look at parallel lines and perpendicular lines. Parallel lines and perpendicular lines. What are parallel lines? If two lines are parallel to each other, that means the lines have the same slope. But if they are perpendicular, that means they don't have the same slope. Or rather, we say that the product of their slope or gradient is equal to -1. We are going to see how we find the equation, considering the equation of parallel lines and perpendicular lines. Okay, let's see how we can do that, and we see how that is possible to find the two parallel lines. When you have two parallel lines, we have this. Okay, y-axis and x-axis. We have one line and another line. They are parallel to each other. That means their slope. If here is theta 1 and here is theta 2, this is line 1 and this is line 2. That means the slopes, the angles are equal and the slopes are equal. They have equal slopes. They have equal slopes and equal angle of inclination to the x-axis. But if you consider the perpendicular lines, if two lines are perpendicular to each other, let me say on the xy plane, okay, so we have the xy plane, we have this line moving in this form, another one moving like this at an angle 90. So here is line 1, this is line 2. So if they are perpendicular, the slope of this one is theta, or the angle it makes is theta 1, and the angle, okay, this one is theta 1, and this one is theta 2. Okay, so therefore we can say that their slopes, the product of their slopes, m1 multiplied by m2 is equal to -1. That means that m1 is equal to -1 over m2. And also m2 is equal to -1 over m1. So that is the product of their slope is equal to -1. We are going to see how that is possible by considering the angle between two lines. The angle between two lines. When we consider the angle between two lines, we are going to see how we can find the angle between two lines. Let's consider the two lines. For example, we have this y-axis and x-axis. We have this line and this line. Line 1, we call this L1 and we call this L2. Okay? Let's say the angle here is theta 1 and the angle here is theta 2 with the horizontal axis. And we have this angle phi. Okay, so using the geometric concept, we know that the sum of the interior angles is equal to the exterior angle. So therefore we can say that the theta 1 plus phi is equal to theta 2. Theta 1 plus phi equal to theta 2. That means we can make phi to be equal to theta 2 minus theta 1. So if phi equal to theta 2 minus theta 1, we recall that m is equal to tan theta. That means m equal to slope. M is slope, that is the slope. And we can say that m1 is equal to tan theta 1. And m2 is equal to tan theta 2. So we have m1 and m2. Okay, so if we have m1 and m2, we substitute using this expression here. We say that tan phi is equal to tan, in brackets, theta 2 minus theta 1. Tan phi equal to tan theta 2 minus theta 1. So if we have this, we can be able to solve and find the angle between them. That is using this. Then we solve and say, using your trig ratios. From trig ratios, we say that tan theta 2 minus tan theta 1, we have tan theta 2 minus tan theta 1 divided by 1 plus tan theta 2 tan theta 1. So we have this as tan phi. Recalling that your tan phi or your tan theta 2 is m2 and tan theta 1 is m1. So we can substitute and say that tan phi is m2 minus m1. m2 minus m1 divided by 1 plus m1 m2. Recall that m1 and m2 are gradients or slopes. So therefore, we can say that if this is removed and equated to 0, then we can find the defined and undefined terms of the expression or the equation. So let's see how we can find the defined and undefined terms. We recall that tan phi is equal to m2 minus m1 all over 1 plus m1 m2. So let's see when it is defined. If this expression is defined, then we have m2 is equal to m1. That means we equate this to 0. So when we equate this to 0, we have m2 equal to m1. That means the two lines. That means the lines are parallel. The lines are parallel. If the lines are parallel, they have equal slope. The lines are parallel, they have equal slope. But if the lines are perpendicular, then we say that m2 minus m1 divided by 1 plus m1 m2, okay, is equal to 1 over 0. Is equal to 1 over 0. So therefore, if we do a cross multiplication, we have 1 plus m1 m2 is equal to 1 plus m1 m2 is equal to 0. So therefore, m1 is equal to minus 1 over m2, or m2 equal to minus 1 over m1. So we have two cases where we can use to solve the equation of a line or lines that are perpendicular to each other. So if you want to find the lines that are perpendicular, if one line is given, you can solve for the second one. And if they are parallel, if one is given, you can solve for the second one. So let's see examples on this. We're given this line. You're given y equal to 2x plus 1. Okay? Find the line parallel to the line above, which passes through point 1, 4. So how do you find the line that is parallel to that? So we're given this y equal to 2x plus 1. Y equal to 2x plus 1. So the gradient here, the gradient or slope is equal to 2. The gradient is 2 because we have this to be equal to y equal to mx plus c. So m here is the gradient. M is the gradient. So if m is the gradient, we say m equal to 2, and therefore a new point that has been given, x1, y1, is the point that is given, which is this. So we have 1, 4. So therefore, we have the slope y minus y1 over x minus x1 is equal to m. So y, in this case, y minus y1, that is 4, x minus 1 equal to 2. So when we cross multiply, y minus 4 equal to 2 in brackets, x minus 1. So y minus 4 equal to 2x minus 2. We simplify further. We have y is equal to 2x, y equal to 2x plus, minus 2 plus 4. So finally we have y is equal to 2x, y equal to 2x plus 2. So we have this. So you recall that in the first or the given equation, y equal to 2x plus 1. But here now, the new equation, which is parallel to the first one, is y equal to 2x plus 2. So we look at the processes we use in arriving at the answer. So we look at the perpendicular perpendicular lines. When the lines are perpendicular, then the product of their gradients is equal to minus 1. So let's solve an example on that. Let's solve an example and see how that we go. So let's see how that balance. So we solve an example on that. So we are given this point. Given that y equal to 3x plus 5. Okay? Find the line. Find the line perpendicular to y equal to 3x plus 5, which passes through point 0 minus 2. Which passes through point 0 minus 2. So for us to find out, first of all, we get the gradient. The one that is given here, y equal to 3x plus 5. Y equal to 3x plus 5. So therefore, here we compare it with the general form, y equal to mx plus c. The gradient is equal to 3. Gradient is 3. Okay, so let's assume that the gradient of the first equation, this is the first one, m1, so we'll call this m1. So if this is m1, we can say that m2 is unknown. M2 is unknown, so therefore m1 multiplied by m2 is equal to minus 1. So that means m2 is equal to minus m1 over minus 1 over m1. So we have minus 1 divided by 3. So we apply the concept of equation of a line. We have y minus y1 divided by x minus x1 is equal to m2. Okay? So when we substitute, we have y1 here, the point that is given, x1, y1 is equal to 0 minus 2. So if that is equal to that, so we substitute, we have y minus y1. y1 here is minus 2, so we have minus 2 divided by x minus 0 is equal to m2, which is minus 1 over 3. So we can cross multiply. We have 3 in brackets, y plus 2 is equal to minus 1 in bracket x. So we have 3y plus 6 is equal to minus x. Okay, so we have 3y plus x plus 6 equal to 0. Or we can say 3y plus plus x is equal to minus 6. We can leave it this way, we can also leave it in this form. Any of the form is okay, provided that the answer is representing the actual thing of what is needed. So therefore, we have been able to solve problems in parallel lines and perpendicular lines. So with this, we know that we can solve some other related problems when we are asked to do that. And it would be nice to try some other problems that are related to that. So with that, we can say that we have done so much. So these are the exercises you can lay your hand on. So we have exercise. We have about 5 questions. We can also make reference to other textbooks and materials so that you can solve more problems in coordinate geometry. Okay, so we appreciate you for listening and for watching the video.